Okay, so I'll be working on some NumPy questions. I've done around 15 questions earlier. I'll start from the 16th one. I've not recorded the videos for the earlier parts, but I think I can just start now. So I'll begin it from the 16th question. How did how to add a border field with zeros? Okay, so the question is saying that if we have an array, say 1, 2, 3, then we have to add borders around it, like borders of zeros around it, like this. So you can see 1, 2, 3 surrounded by 0. So basically we have to do this. Before doing the 16th one, I think the 15th solution that's here is maybe beneficial for you guys. So because I think in the 16th one too, we have to use the slicing technique. I'll just show you the what I'm thinking. Suppose the existing area is this. And now we have to add. Now we'll create another array of 1, 2, 3, 4, 5. So basically length of this plus 2, length of this array plus 2, it will be 3 cross length of this array plus 2. Create an array of so this will create an array of, regardless of what this can be, we can just add it in this manner, so that we will get an array, 0 array of this shape, means 3 cross length of this plus 2. If this array is maybe say 2D, we can get the length of the number of rows and then add 2 to this. Right now we have added column plus 2. Here we can keep row plus 2. Now I have to add this array here. For that I have to grab the first row of the 0 array. I'll select the first row of the 0 array, and in that first row I'll select the columns from the first position to the second last position. So it will be 1 is 2 minus 1, and just replace it with the array. Yes, you can see that 1, 2, 3 is here, and it's surrounded by. So I said that this will be helpful because the same slicing technique is used here too. Just here what we did was that we have array of ones, and in the non-boundary elements, we have to add 0. So we selected, for the rows we selected from here to here, and for the columns we selected from here to here, and replaced that with 0. Let me see what into the there's done something else, but okay, I think our solution is good too. What is the result of the following expression? So you multiplied 0 with 9. How does it come? Nine. Okay. I'm not getting the question. What does this mean? Do they want the answer in this format? That what will this return? Nine is not false. Is this is? I think they want values like this on p dot nine. In the next section, maybe what is the value of this? It will be false. It will be false. And then NP, what is this? This doesn't make any sense, but let me just check it once if this is the answer they want. Why is this false? What is the answer that I wanted? Okay, I just had to print all these things. Not a big deal. It's not just. There is no logic involved here. Basically, they want the answers related to this. So, okay, no issues. Let's move on to the next question. So create a 5 cross 5 matrix with values 1, 2, 4, just below the diagonal. Just trying to visualize it what they are asking. So basically they want here 1 2 3 4. These diagonal elements are there and they want these values as 1 2 3 4. So basically this is a slicing problem. And 2.1s, so make it 5 cos 1. So what I'll do is that I created an array and I'll now find out a way of removing these values and putting 1 2 3 4 here. So what can I do? I select from here to here. What I'm thinking is that if I select arrays from here to here and then loop over it and replace this positions as 1 2 3 4. So I can select it this way. The rows will be from 1 to the last one and columns will be in the particular column it will be I plus 1. Now it will be I only because we want to select this and then this and then this and then this, right? So basically it will be I plus 1 I plus 1. It's not working. It is coming as empty. It should not be like that because I've selected this row at the start. And the 0th column. I've done this mistake here. It should be comma here. Yes, we have done it. So you can see the numbers here as 1, 2, 3, 4. What they wanted, I've done it. I think this I've used NumPy's indexing here, but not any functions like NumPy whatever there is. So let's see what the actual solution is. This is some different function. We can check what it is. It's, even though if you have come up with the solution, you can just look into the more optimized one and understand, basically gain more knowledge. Okay, so what I can see from here is that this thing, the diag method, the diag function here, what it does is that it selects the diagonal elements of an array, and this value here, basically its definition is here. So if it's 0, then it's the main diagonal, and if it's greater than 0, the basically the values above the diagonal, and less than 0, like in our case, it's selecting and it's replacing it. Okay, so you can select these values and replace it basically. Okay, fine. Let's go to the next one. Failure to check what button. I'm not getting what they want. What is check? What they want? 0 binary values. Okay, understood. So basically they want 0, 1, 0. Okay. For this, let me just create a board here. what can I do here? So I can do one thing, 0 comma 0, 0 comma 1, 0 comma 2. So we can do one thing is that we grab one row and then fill the alternate values with 1, and in the next row we change the order and then fill the alternate values with 1. This way we can go on solving it. So what is the length of this? Should be we can just for visualization. So what we can do here is that we select that particular column. So I'll do one thing. If I is even, then I'll select one pattern of altering the consecutive values as 1, and if it's odd, then I'll select the other one. So if I is so 2, I don't want to add 2 for loops here. Okay, so and to check if it's working. Okay, so for you can see for these positions it's already changing the values. Now we have to target for this, basically the odd positions, odd indexes like 1, 3, 5 and 7. So for j if else, okay, we have done it. So this is the solution, but I have it's n square complexity. We can think of improving it. I'm sure there is a NumPy slicing way that we can use, that I'm aware of as of now. Can do this. Okay, so here they have done something. Checkerboard. So they have probably done some optimized way. Checkerboard displays the slicing notation start, stop, step. Okay. Got it. So they have started from the first in this for the first row, and then they took 2 steps in every row, and for the columns they started from the 0th only and took 2 steps and filled it in. And here they started it from the 0th and the column from the first index. Understood? Basically this is the J part. This okay, nice. So you can see that even though I've solved it here, I have got to learn the slicing techniques. Like this is a step version. This is so basically start, stop, and step. I knew about step, but I forgot it. Now I have learned it. So you can see that solving these things is actually very important to clear your thoughts, your problem solving skills, and the coding skills. Not unsorted ratio. I think they also provided the same answer. Yes. You see, this much reduced to this much. Good. So what is this? Consider a 6, 7, 8 shape array. What is the index? Etc. The 100 element. I'm not getting it what they want. Consider 6, 7, 8 shape array. You mean 3 arrays of one of 6, 7 and the other of 8. What is the index x, y, z? Okay. I'm not getting it what they want. Let me just see guys, I'm not understanding what they actually want. Consider a 6, 7, 8 shape array. What is the index of the 100 element? This portion I understand. They want the index of the 100th element. So okay, I get it that this may be the x, y, and the z. Basically, the like in uh, image we have the width, height, and the number of channels. So uh, 6 planes. First of all, how to create an array of this shape. So 2 is the channel, 3 is the number of rows, and 4 is the number of columns. Okay, understood. So basically, you have to do this. I think this takes something else. Let me give it like this only. Six. So now I have to, for the 100th element, what do they mean? If you have to flatten the 3D array into one long, okay, this, that. So what is this? This way you can basically get the documentation. Converts a flat index or array of flat so indices array like an integer array whose elements are tuple elements. The shape of the array to use for so array dot types. So here I will pass the spot and so the 100 element will basically be the 99th element, and next will be shape. Just trying it out, I don't know. Is this the answer? Yes, I think this is it. So here I can see that if you want any number of elements, say 7106, okay, this is basically the shape. So if you want the array like integer array whose elements are indices. Let's get more detail. I think this should solve it. So if you want a 2D portion, then I think it will say here we flattened it out, right, in this place by passing the 99th index. So if we pass maybe 99,101, it will just return the 2D section of it. I think we should go into it deeper later, but okay. So okay guys, I think I've solved around 5 questions. So yes, you can just practice it out and make it more clear. It's very helpful. Okay, bye.